Hello, this is Module 7, Section 7.3, Day 2, Notes, Interior and Exterior Angles of a Circle. We have a little bit of a review to start with and then some new stuff today. So the first review is, remember, where was my cat that just tipped over a box? I'm so sorry. Central angles have the vertex at the center. So when we are looking at, here's a central angle, so this angle down here, and we know its intercepted arc, and we know that the measure of the angle is exactly equal to the measure of its intercepted arc. Inscribed angles have the vertex on the circle. And we have a couple of examples of inscribed angles, one right here and one right here. Can be made by a chord and a chord, or a secant and a tangent. But that angle and then its intercepted arc, or the arc that it hits the sides on, this should look familiar to you from 7.3 Day 1. And we know that in either case, the measure of the angle is equal to 1/2 the measure of that arc. All right, here's the new ones for today. Interior angles, so angles on the interior of a circle, but not at the center. So an angle like this, here, this one, then actually we need two arcs. We need the intercepted arc out here, where it hits on this side, and then the arc of the vertical angle, so vertical angle on the other side of the intersection, and its arc out here. So when we do interior angles, we need two arcs, and we know the measure of that angle is 1/2 of its arc plus the arc of the vertical angle. Okay. Exterior angles. Interior angles have the vertex on the inside. Oops, I forgot to write that down. Vertex is on the inside of the circle. Not at the center. It'll work if this formula will work if the vertex at the center. It's just much easier to do this, the central angle idea. You'll get the same thing. It's just easier when you got vertex at the center to go this route. All right, exterior angles, vertex is on the outside of the circle. All three of these are examples of exterior angles. So this one, this exterior angle, and this one down here. In all three cases, again, we need two arcs. We have a little arc and a big arc. On this situation, here's the little arc, and here's the big arc. And in this situation, little arc and the big arc. For all three of these exterior angles, the measure of that angle is 1/2 of the big arc minus the little arc. Okay. Now, there is a special case. And it only works for that last situation, the ice cream cone exterior angle formed by two tangents. Remember, a tangent line just skates right along the edge of the circle, so it just touches here and just touches here. I like to refer to this as the ice cream cone. Doesn't it look like an ice cream cone? Yes, it does. Come on. So for the ice cream cone situation only, this is the only time it works, the measure of the angle plus the measure of the little arc equals 180. That's nice to know. This formula will work for that ice cream cone situation, but this one's faster. Again, it only works for this ice cream cone situation, for the last one. Okay? All right, there's the formulas. Let's go do some problems. Okay, so measure of arc DI is 80, the measure of arc TE is 20, find the measure of angle 1. Let's put that information in here. Arc DI is 80, arc TE is 20, and we want to find angle 1. This is an interior angle, which means the measure of the angle is 1/2 of its arc plus the vertical angle arc. So that angle is what we're looking for, is 1/2 of its arc, 80, plus the arc of the vertical angle, 20. 80 and 20 is 100, 1/2 of 100 is 50. So the measure of angle 1 is 50 degrees. Okay, number 2. Let's see, arc WA is congruent to arc RE. Measure of arc WA is 100. The measure of arc WR is 130. Find the measure of angle T. All right. Arc WA is congruent to arc RE. So this arc here is congruent to that arc there. Arc WA is 100. Oh, well then that means arc RE is also 100. The measure of arc WR is 130. And we want to find angle T, this one out here. All right, angle T is an exterior angle. Which means that the measure of the angle is 1/2 of the big arc minus the little arc. Okay, well, where's these arcs? From angle T, when it first hits the circle, that's the little arc. And keep going the sides out till it hits the circle again. There's the big arc. Well, the big arc for sure we can see is 130 minus, little arc we don't have. We're going to have to figure that out. We know that the three angles in a triangle add up to be 180. Absolutely, but we're not doing triangles. Silly Mrs. Rachel. The degrees in a circle add up to be 360. So let's see, we have 100 here and 130. That's 230. And another 100 is 330. So 360 minus 330 makes this 30 degrees. There's your little arc at 30. 130 minus 30 is 100. 1/2 of 100 is 50. Measure of angle T is 50 degrees. All right, look at number 11. Given the measure of angle RTE is 150 degrees, RTE 150. Measure of arc RE is 130. And we want to find the measure of arc MH. All of that, that's what we want to find. Let's call that X. Now, the angle that they gave us, 150, that is an interior angle. So the formula there is the measure of the angle equals 1/2. Do you remember? Arc plus arc of the vertical angle. All right, now this time we know a little bit different stuff. We know the angle this time, so I'm going to put that over here. That's the angle is 150, 1/2. Its arc from that angle is 130 plus arc of the vertical angle. That's X. That's what we're looking for. Okay. Now, I don't want to distribute this half through. I don't want to deal with the fractions. So what I'm going to do is to multiply both sides by 2. So if I multiply this side by 2 and multiply this side by 2, left side gives us 300. Right side, this 2 takes out this half, and we're left with 130 plus X. Subtract off the 130, and that's 170. That is what we're looking for here, so we'll say the measure of arc MH equals 170 degrees. Okay, let's look at this one here. Given the measure of angle OSN is 220. OSN, arc OSN, all of this mess down here is 220. Okay, and we want to find angle C, this one up here. All right, 2 ways to do this. I'm going to show you both ways, and then you can decide whichever way makes you happiest. First way is to recognize that this is an exterior angle. And the formula for an exterior angle, you remember it? 1/2 big arc minus little arc. And that angle that we're looking for, 1/2 of, well, the big arc very clearly is 220, minus little arc, here's the little arc back here. Now to find that, 360 in the whole circle, 360 minus 220 leaves this as 140. So we can put in that little arc of 140. 220 minus 140 is 80. Half of 80? 40. So measure angle C equals 40. That's one way. The other way is that this is an ice cream cone. It's an ice cream cone situation, which says angle C plus arc ON equals 180. We're trying to find angle C. Arc ON is 140. So measure of angle C is just 40. Either way works. Whatever makes you happiest, whatever you see. All right, a few more problems to go. I think there's just 2 left for this day 2 of notes. Yep, just these 2. So here we go. Given angle R is 52, arc IL is 23, so this mess in here is 23. I want you to find arc CE, this one up here. Let's call that X. Well, what kind of angle are we given? This is an exterior angle. So the formula is measure of the angle is 1/2 big arc minus little arc. Plugging in the stuff we know. The angle this time is 52, so I can plug that in. 1/2 the big arc, x, minus the little arc, 23. Again, I don't want to distribute this half through. I'm going to go ahead and multiply by 2. 2 times 52 is 104, and here the 2 takes out this half, so that leaves us with x minus 23. Add the 23 over, and x is 127, which is exactly what we're looking for. The measure of arc CE is 127 degrees. Okay. This guy over here, let's see what we can figure out. Well, let's start up here with this exterior angle. Which means the measure of the angle is 1/2 of the big arc minus the little arc. That angle, 60, 1/2, the big arc, follow the sides out, 155, minus the little arc, x. Again, clear the fractions, multiply by 2. 120 is 155 minus x. I'm going to subtract that 155. That gives us negative 35 equals negative x. Divide out the negative 1, and x is 35. Nice. X is 35. Now, once we have x is 35, we can start to think about finding y. Because look at this arc right here. This is the 35 plus 155. 35 and 155 is 190. Then if I do 360 minus 190, that's 170, which means this angle right here, excuse me, not angle, this arc is 170. So for angle y, that's going to be an inscribed angle. And so we know that the angle is half of its arc, or that angle, y, is 1/2 of 170, and half of 170 is 85. There we go. Okay, now our question of the day. For 7.3 day 2, your question is, what is the one item that you should have right by your door of your house as soon as you come in your house from being outside? What's the item you should have right by the door when you come in your house? Here it is, bottle of hand sanitizer. So when you come in your house from being outside, you should immediately hand sanitize or go to the bathroom, wash your hands. But this is always nice to have right by the door as soon as you walk in. Hope you're staying well, and I'll talk to you soon. Bye.